is all the name. Okay, so for example, the first one that you have in there, so of this, I just draw out one of them. Something look like this, and you have this way. All this point, this one, in here you have four vertex. Okay, all these dots are called vertex. And any diagram like this, or you have any random diagram, I can have something look like this, and then go to another way and loop it back again. So these are all called network. Okay, so the network have, some of the network have directions, which is going through like this. Micro directions. This is directed network. If you look at it, I have directed network, I have undirected network, and the network in here, from, if I call this as a point, or this is a point D in here, this is a point A. So from A to D, if I don't have the arrow in here, so that means I have multiple way of getting A to D. For example, from your house to my house, you have multiple way can go in. This is multiple edges, that means multiple way. And this one in here, it go out and it come back again. This is called a loop. Yes. And these two is multiple edges. Yeah. What else is in here? Oh, degree of the vertex. Okay. So if I want you to find the degree at vertex D, so this is a dot. I want to see how many branches going up. So in here, you have not only going out, don't worry about going out or going in, how many branches come from here. So that means this is degree 3. And at this point, you have degree 1, 2, 3, 4, 5, 6. So this is degree 6. Yeah, does it make sense? Yeah, oh good. And what is degree for this one? 4. Yeah, that's what you have to do. Okay, and we talk about the loop and done. So all the name in there, all good? Right. Then we are going to look at the next one. You have a lot of names, you need to remember them all. A walk, if I say I have a walk, that means you go through anywhere you like. Oh, so for example, for this one, if I go for a walk, I can go from here to there to here and then look back. I can go anywhere I like and then look like this. Okay, or I can just have a short walk, which is I might just go from this point to that point and here I stop. That is a walk. Alright. And there is no restriction on the walk. You can repeat the vertex, you can repeat the edge. But when you go to the next one, which is a trail, okay, so the diagram given to you look like that. Right, in here, you are not, a trail is no repeat edges, you cannot repeat the edge, but repeat vertex is permitted. So now you can draw one for yourself, you can draw anyway, as long as you do not repeat the edge. So if I start from here, I can go there, I can go here, I can go there, come back, and come back. This is if I go this way, go up, go down, go across, go down. Is that right? I cannot go back again. If I go back, I repeat the edge. Okay, so draw one for yourself. Draw any particular one. Yeah, use a pen to draw it out. So in here, what do I do? I have all the vertex A, E, D, C, B. Just then I go from A to E, E to B, B to D, D to C, back to B, back to A. Yeah.
Wait, do I draw on this?
Yeah, you draw on that. Yes, yes, you draw on that. Okay, this is just a trail, right? Now, I want to draw another diagram up on that one. Is yours one repeat, cover all the edges? Oh, yours one is already cover all the edges, which is this special one that you draw. Okay, that include all the edges. Look at my one. My one doesn't include this edge, but yours one include the edge, right? Look at the next statement. Traversable graph. When you have something is traversable graph, that means you cover all the edges and it's a trail. Okay, all good. So remember that word, highlight it. So sometimes they ask you to draw a traversable graph. That means you need to cover every single edge, right? So that means with my one, in order to cover all the edges, which point I have to start? I have to start from here, right? Yeah, I need to go from here, and I need to go this way, go back. Yeah. That means I will able to cover every single one. Okay, oh good. Right. Next one is all about definition. Write them all out and post it up. And the next one is a path. A path, you have no repeat edge, no repeat vertex. So look at the diagram again. How can you draw a path? A path you can have two types. One is open, one is closed. So when you are closing, that means you start and end at the same point. Open, of course, you start and end not at the same point. So in here, if I want to have a path, what I can do is I can start from here. You can not allowed to repeat any of the edges or the vertex. If I go this way, that means I stop here. Yep, that will be a path. Okay, if you want to be the same start and end, that means I can go from here to there to here, there and there. This is the path. I don't need to cover all of them. Yes, just draw one for yourself. What path do you like to have? And then the next one will be circuit. So that means it must close. It must start and end at the same point, with no repeated vertex and no repeated. So by looking at this one, it just go one big round. That is a circuit. Okay, or a small one like this. That will do too. Okay, right. Cycle. Okay, cycle is no repeat edge, no repeat vertex again. Okay, oh, for the circuit, yeah, you are allowed to repeat the vertex. That means you can go here, come back, and then come back again. But that doesn't make any good, isn't it? So if I go, I have too many lines already here. I can go here, I can go back like this. If you repeat the vertex, but not the edge. Okay, right. The last one is cycle. Cycle, no repeat on anything. Yes, you just go on, look at it. And then you have a new name on it, which is on the bottom. Hamiltonian cycle. The last one. Yes, this one. Which you remember what does that mean? You visit every vertex exactly once.
Yeah. Wouldn't that be the same as just
they are all the same. Yes. Yes.
And then a cycle.
Cycle.
Do you have to cover every?
No, you don't have to. Cycle, you don't have to. Yeah, you can have a small cycle, you can have a big cycle.
As long as it comes back to the same?
Yes, yes, it has to come, start and end at the same point. Okay, right. And the next page you have two diagrams. The top one is connected and the bottom one is not connected. That's very obvious. How is that difference? Okay, and the one underneath, that's the one that is important. And this one, isomorphic. So if you look at the first diagram I have, oops. So I have A, B, D, C compared to the other one. For them to be isomorphic, I just compare these two. Look at the vertex at A. It has degree 2. Look at the vertex at A in here. It also degree 2. So every single one, they have to be the same. Vertex C, degree 3. Vertex C has degree 3. Right, that is the first criteria. And then from A, I can go to town D. I can go to town C. And from A, I should able to go to town C. I should able to go to town D. It has to be exactly the same. It just formed differently. That's called isomorphic.
So just the degree and
the
edges.
The edges, yes, it have to go to the same places. So for example, B must go to D and C. My B, yes, I can go to D, I can go to C. If I have another one, go to the A. That means, they are not isomorphic anymore. Oh good, yes. And the weight. Okay, so if I have 3, this is 5, this is 7, this is 4, maybe this is 6 somewhere in here. So these are, for example, from town A to town D is 3 kilometer. From town D to town C is 7 kilometer. So all these are the weight. So it can represent, it costs you $3 to go this motorway and costs you $7 to go to that motorway. Yep. So it can mean different things in the diagram. Yep. Okay, so another name, do you remember? Eulerian circle. So that means if you have a network diagram with only 2 odd edges, that means you were able to create a Eulerian trail. Okay, so you start and end. So this one is go. Oh, I already draw it there. So you start from here, you go up, and then you go down. See, you trace it up. So you're able to go through every single vertex. So as long as you're able to find this vertex, degree 3, and you have another one, which is right here, also degree 3. If you have 3 degree 3 or 4 degree 3, you will not able to make it. Yes, makes sense? Yes, yes, okay. And the last one is, if it's a circuit, remember circuit has to start and end at the same point. So the one on the bottom, that means you have to start and end at the same point. You only can do that if you have 2 even, what's it, has an 1. Oh, every single graph has even degree. So every single one, you cannot have odd, no more odd, must be all even. So you see B is even, A is even, so you go this way. So A, B, C and D. Even degree, even degree, even degree, even degree.
Even as in they have 2 each.
2, yes, or maybe 4, or maybe 6,
Oh.
but now cannot have odd. Yes, must be even degree. Okay. And the last one, spanning tree. Okay, spanning tree means if I have, okay, so A, B, A, B, C, D. Okay, so if you have a 3, this is a 5, this is a 7, this is a 4, 2 and 1. So if I want you to find a spanning tree, okay, spanning tree means I want to connect to every single town. So in here to connect to every single town, that means I might be connecting here to there. I might be connecting these 2. Okay, I might connect this one. Then I connect, if I connect this one, that means I can connect every single town already, right? From A, I can go to B by going here. E can go to B, E can go to A, D can go to C. Is that right? Right. This is called spanning tree. And I can have another spanning tree. I can say I connect this one, A to B, then A to C, and then I can have this one and that one. That is a spanning tree. Yes. Okay. Now the last one is it can be a lot. Okay, as long as you are not allowed to close it. If I close it, that means it's not necessary, isn't it? I can go from here. Why don't you want to close it? So the next thing we are going to look at is minimum spanning tree. So when I'm looking for minimum spanning tree, that means I want the least number that I can get. So I will start with the smallest number I can find in the diagram, which is this one. Okay, from this line, oh, I forgot to put number in here. Now, I have 2 vertex. I'm going to pick the smallest out of this vertex in here. This one goes to 2, this one goes to 3. 2 is going to be the smallest. This is the next line I'm going to pick. Now I can pick from here, I can pick 3, I can pick 5, or I can pick 4 from this vertex, I can pick 4. From this vertex, I can pick 3. So actually these 2 are the same. So it's up to you which one you want to pick. I'm picking this one. Okay, now I pick again. So this is 7. I will not do this one because otherwise close it up. So this is definitely a no-no. And then I can pick this one. So now the 3 is the smallest, so I'm going to pick this one. And have I connected every single point? Yes, you did. And this is what we call the minimum spanning tree. Yes. Okay. Yeah, that's all the name. Literally name and more name. Now we can try out this exercise. Yes. We can go.
Is this one or this one?
This one, yes. So for any of the, if you have 4 vertex, so if you check, okay, so if I just put any 4 vertex to join them up, I can have 3 lines. I join everything up. So if you have 10 vertex, what do you think? How many do you think I need to join?
No.
9. Yeah.
So can I do like
One. Yeah, that will do. That will join everything up. So what is the minimum number of edges? Yep. You can join it that way, or you can make it nice by joining it this way, isn't it? It's still 3. Yes. This is the minimum spanning tree. So start from the lowest line, that the lowest number you can find. Yes, that's the first line you draw. Okay, and then you are thinking of the vertex E and F. Which one will give you the smallest up from the? Yes, yes, this one or that one. You pick one. Yep. Okay. Now you pick either it can go this one, can go that one, can go this or that. Which one is the smallest number now? Yes, I'm going to pick that one. You keep picking the smallest. Now.
and then it will be this.
Yeah, that will be that one. Okay, that will be
The
that one.
smallest.
Yes, which one you want to pick? Pick one. And the next smallest. Yes. So how many points we haven't connect? We haven't connected A. We haven't connected D. Okay, to connect the A. Yep. To connect the D. Yeah. Oh, this one should be big. This one is the smallest.
Oh.
Yes. Okay. Now, to find the minimum spanning tree, the weight of it, that means you add up all the lines that you just added. Yeah, all the lines, add them all up. Done.
Is there a right answer for this, or does this just depend on what you?
Oh, it's always the same answer. It should be the same answer.
Oh.
You have 29. Okay, do we pick the wrong one? Okay, so you have, do you have the order? 1,
1, 4, 3, 6, 4,
4,
5.
5, 2, 4. Yeah, you have it right. Let me check my book now. Yeah, I also calculated 29. Yeah.
Okay. Also this one.
Mm.
Do I start with A? The minimum is still the lowest one, right?
Yes.
So would I go?
Which line
Oh
is
wait, it
this?
says all the towns are connected.
You need to connect all the towns, so that means you need to connect all the vertices together.
So would we?
Yep, you can start with that one. Yep.
Yeah.
Pick the smallest number.
And then here. But then, am I allowed to?
Not that one. This one.
Am I allowed to go over the line?
What do you mean? Oh, repeat the line. You don't want to repeat the line. Yes, and you don't want to form a circle as well. So you don't want to form a loop like this.
Okay.
Yeah, no circle.
This.
So you have this and that, and then followed by what is the lowest from here? Yes, that one will be the lowest. And then the lowest again. Yes, going down. Yep, another lowest.
6.
Yep. You don't want that because otherwise circle, it becomes a cycle.
Oh,
Yes.
but it doesn't go back to A.
You don't have to. You don't have to. So you are looking for minimum spanning tree. So that means you just need to connect all the time.
So kind of.
Yes. And that will do. So if
And it doesn't connect to C. Oh, it doesn't.
yes, it does. Your C is
This one.
yes, this one. This one was your first one.
Oh.
And that will do. Yeah.
Wouldn't it just be?
And go up. Yes.
Oh, that's it.
Off by one again.
Oh wait, that was this one. This would still be the short. Oh.
What do you want? Okay, count A to count E. Okay, you want the shortest from A to E.
So wouldn't I go here?
Okay, there are a few ways you can go A to E. So you can go this way. Okay, see whether there is a shortest, or you can go this way, or you can go that way, or you can go cut off. See which one is the shortest. There's a lot of different ways.
Oh, so
Yes, that means you need to look at one by one. This one, the one on the top, definitely no, because that look,
56. Yeah.
is that look big?
Where's the 56?
If you go from here, okay, it just goes saying that from A to E, so you can go this way. That means 56 plus this plus this. Yes, you can go that way.
Here.
Yep.
Oh yeah. So there's
Yes.
4 ways.
Yes.
Oh,
Or you can go.
there's a lot of ways.
Yes, there's a lot of ways. Some of them already look big, so you don't want to calculate it. You do not even want to try it.
I'll do that one after. That was really good.
Yes. Tracy. Very time consuming.
What's this? But how does it go back to D?
You can't. There is no route from E to D, so that one is not.
So then C,
Yeah.
D, F, E, G, A, B, C.
Yes.
Oh, wait,
that's it.
C.
Yes, that's
But it
one.
doesn't go through here.
It doesn't. As long as you go through every vertex once, right?
As long as it.
Yeah. Visit every vertex.
Oh, okay. So C, D,
Mm.
F, E, G, A, B, C.
You visit every single one once. Yeah. Oh no, every single one is fine. The one that is not.
Oh.
Yes, that is your D. Because you cannot go from E to D. Yes. Mm. Mm.
Wouldn't it just be
Yes.
here and there?
That's right. That will be the shortest, not the 72. Mm. Yeah.
69.
This is just for the first part. Pick up the friend from Newcastle and then need to drive to Leeds. So which is here. Mm.
So here.
That means the person is going from here to there, and then it go down here. Yeah.
And then 15.
And then 15. Yes. Can be. Yes.
And 31.
Mm. Yeah, it can be 31. So.
Or would this be shorter? Like if it was straight down here?
And is that possible it go this way? So think about these three number compared to those two number. I think the first number. Okay.
12
12 plus 15 plus 31.
58.
Yeah.
And then 13.
Plus 42.
Oh.
Yes, that one. Look,
So
yes.
it would have to be here.
Yeah. Pick up the
Yeah.
friend.
Then
Come
drive back.
Yes.
42.
Yes.
And then 26.
Yeah, hopefully that will be the shortest.
So then 69 plus 30.
Mm.
Are there multiple ways?
But you want the shortest one. There is a lot of different way. Yes, that's why it's very, very time consuming. You need to be so careful.
So we find that. Do we always just find the shortest way?
Most of the
Usually,
time.
yeah.
Yes.
And as long as, for this one, as long as they all connect? Or does it have
Yes, all the time. Yes.
7? B7?
Yes.
And then here?
Yeah.
Here?
Probably not.
Here? Oh.
Okay, let's pick
Wait,
the
does it have 2?
Okay, let's pick the shortest, the smallest number in here. Right, that will be the first line. And from there, what's the next shortest? Yep, I will pick that. Okay. Yes, I will go and pick the shortest one. And then, yep, that looks like it's the shortest. Yes. Yep. Oh no, you don't. This one you close it up. You cannot close it up. So one more. This is point already connected. So you don't want to come here again.
Oh, so it's done. Oh, and D.
Yeah, D. Yes.
Oh.
Yes. Making sense?
Yeah. So then I add them and then times by.
Yes.
So 2, 5, 4.
Spanning tree, that means you connect from town to town. Yeah, from vertex to vertex. Yeah, no loop. Mm.
Wouldn't this one be on it?
This one, I want is not. Yeah, this one is. Yeah. Mhm.
Yep, this one is.
This one is, yes. Mhm.
That one is.
Yes. And this one.
Oh, but you have to go.
Yeah, this one.
Okay.
Yeah, look at this one. It doesn't have a line. From 3 to 5, right? Yeah, so
okay.
this line shouldn't be existing. Otherwise it is. Yes, because there's no route to go there. Mm. Yes, it must be from that route there. Yeah.
So this
Mm.
would be these two other times 50.
Yeah.
And then oh, they can do that.
Yes, they can do that or go from
Oh,
the top.
X.
Mm.
Oh. And this is 60?
Okay.
Or this is 60?
This is, those two are 60, the one outside is 120. Mm. Mm.
So then he would
He
choose
can,
this one?
yeah, you can try to see what is the distance, what's the time, yeah. Oh, you cannot
Oh,
add
wait,
up.
3 times.
Mm.
And then plus
3 times,
60.
okay, times is equal to distance over speed. Because speed is distance over time.
Distance. Wait.
Speed,
Distance over speed.
yeah,
So
speed
3 over 6.
equal to distance over time, so times equal to distance over speed.
So then that's 3
Over 60,
over 6.
that would be the time, plus it by,
And then plus 25.
Yes, yes, yes. Yeah, 24. Add up the 2 times plus that. Yep. Okay, and then you change it to degree. Yes. That would be 15 minutes, 30 seconds. Right. And try with the other one. See that one. Is that one
This one?
faster? Yeah.
Plus 22 over.
Yep. Yep. Mm.
60.
Yes.
So this one's faster.
This one's faster. How much faster
Thanks.
compared to the original?
Oh. So then we choose
Yeah.
this one.
This one.
And then the original is 7 plus 13.